been teaching math and what interests you, and
Okay.
a brief introduction about yourself.
Okay. So I'm Snehal Deshpande Roy, and I have never been a math teacher few years ago. I have been teaching math for, let's say, 10 years now. Not on commercial level. Recently, I joined Cuemath, and that's the only time I'm teaching it commercially. Before that, I graduated as a software engineer, as most of us are. And I was drawn towards animation at that point of time because it was a booming industry, and we did a project in animation, which really, at that time, it was really nice. And we thought, why not try this field out? And uh, I went on to become a technical director for the motion capture studio. I worked in that position for quite a long time before taking an early retirement from that career, mainly because of my commitment towards my family. That was the time when I was expecting my firstborn.
Right.
And after the birth of my first child, actually, everything changed for me and my husband both. As a family, we became very different people, what we used to be. We were more outdoor and social and um, quite career oriented, and from that we made a big u-turn from being family oriented, and then it opened our eyes towards many things like food and education to start with. And then we started questioning every aspect of it, and we ended up deciding that we want to homeschool our child. So I have two kids who have never been to school, and I have been teaching them solely myself with my husband, of course. And we also run a learning center. So what we basically do is, while teaching our kids, we also involve other kids. So currently, we did it in the city. Like we were in Dubai for a brief period of time where we created a homeschooling community there. We had a beautiful group going on there. And when we moved to India, I think we did start a learning center in Pune, and there in that 2 years of engagement with the learning center, we discovered that it's better if it's going to be self-led, where there are not going to be any sessions. If we are going to learn a center where children are going to have the say in what they want to do, then better to put them in a dynamic environment. And that's where we took a call that we want to move away from the city. And I think in last January 2020, we moved our base from Pune to a nearby village. We are currently on the farm. Uh,
Mm-hmm.
Luckily, thankfully, they have many children over here. There is also an orphanage. So currently, we are running a small learning center here in our front porch, and kids are happy, learning different things from us, and many things we are learning from them, about nature. And it's like a very nice give and take that is happening.
It sounds interesting that you said that you run your kids are homeschooled one, and you teach other
Yeah.
kids as well. So
Yeah.
where is math in all of this? Why is there this? I mean, do you think there's a fear of trying to learn math? You think there's a, most case students, not just your kids, across. Is there a sense that you get that there's a hesitancy or a fear of math, that it's a very complex subject, we will not be able to do it? What are your views on that?
Not at all, actually. With my children, no, there is no fear of math. For first reason would be because they don't have any fear of evaluation. To be
Okay.
honest, because they know that they're not going to be judged once
Mm-hmm.
they learn something.
Mm-hmm.
They're not going to be judged whether they understood it or not, and they have ample time to do their discovery on the subject that they have learned. That is first thing. But yes, I did come across fear for math while for a brief period of time when I was teaching kids who are school going. And there is a
Mm-hmm.
distinguished difference between the kids which are going to school and the kids which have never been to school, or they have been in an environment where schools don't have any importance, or so like village schools where teachers are hardly there, and they are on their own.
Mm-hmm.
So yes, there is no fear over there.
Why do you think the students have this fear? For the students who you did say had fear of maths, one is the
Uh-huh.
obvious testing of it. that you mentioned.
Right.
But what else can
Right.
you sort of add to that?
So, see, first of all, we need to understand that why fear comes in the mind, and specifically
Mm-hmm.
for maths, right?
Mm-hmm.
It's basically because of the structure of the maths that we have created. It's like it's a problem and solution structure that has been created
Okay.
for math. Let's
Okay.
say if I ask that same child to write an essay or write a story, you will
Mm-hmm.
see that there is no fear over there. Why
Mm-hmm.
is that? Because there is a creativity, there is scope for, there are many ways to write that essay, and each child will write it differently, and that every approach is equally appreciated. Whereas in math, we are so used to treating it as a subject, which is like there is a problem, there's this one problem, and there is this one solution, and there is one way of reaching from the problem to the solution, right? So this is like, if you visualize from child's point of view, they're standing on one mountain, that is a problem, and another mountain is a solution, and then there is one bridge, and if they have to do each step correctly, and if they don't, if they miss, they're going to fall in the valley of errors. So that is going to create fear and anxiety. If we
Right.
start treating the subject as creatively and welcoming different approaches, I'm sure there would be less fear or phobia about the subject.
So apart from that's a very valid point. Apart from that, what else do you think uh, math sort of brings for a student who learns it? Is there any practical applications? What do you see as the other benefits to a person or a student of learning maths?
Sriram, could you please repeat the question again if I'm just missing my point?
My point was, what are the real life benefits of learning
Aha.
mathematics?
So, yes, so the real life benefits would be that once you understand why we are learning it and from where we are learning maths, it makes more sense of the world that is around us. There are many. Like, let me give you one example. Actually, if you see, every discovery that has changed the world today has been drawn, or it's inspired by nature, and that happened because of their understanding of math, and those people were able to connect it to the outside world. I talk about, that I talk about fractals a lot because that's one of my favorite topics. But let's say, one person took found this randomness in the clouds and trees and seashores and rocks, very interesting, and he found out if there is any mathematical formula, and turns out there is. And then he made a theory about fractals which changed the world. Now there is this other scientist who was struggling, and he's a electrical engineer, and one day he went for this guy's workshop. He saw what fractals are, he comes back, and he takes inspiration from that, and uses his math knowledge and the something that he learned from this other scientist, and creates an antenna which can take signals from for more than one frequencies. You remember the antennas we had in our childhood, like where there was a
Right.
TV and there is one kind of antenna, and he managed to design an antenna which will catch radio signals also, TV signals also. In just one antenna would do both the work, and then that went on evolving, and we ended up with mobile phones. So we basically,
Right.
the reason we have mobile phones or wireless technology is because of the fractal model, which was inspired by nature. So the thing that happens, the real life application, I think it's always there once you are able to connect maths, what you're learning in the textbooks, to the real world or the world outside you. So there are
Right.
endless applications actually.
Say a person who knows mathematics and understands it well versus a person who doesn't understand it. What do you think
Right.
is going to be the difference in terms of the way they perceive the world itself? Do you think that learning mathematics helps you look at nature and the world very differently? One is
It
to use it when
absolutely does.
it's slightly different from the previous question. The previous question was, you said if you're able to connect mathematics to the real world, you can find out applications, right?
Yes,
But
yes, yes.
what if your whole perception of how you look at things changes by learning mathematics? How do you think it does, if it does change your perception?
It definitely does, because let's talk about, as you said, a person who is good at math versus the person who is not very good at math, or they think they're not very good at math. What could be the fundamental difference between them? We can, one of the things that we say, if we are connecting last question to this, is maybe they found some way of connecting to the subject or the language that math is, and which made it very easy for them. They have a broad understanding which is happening, beyond the calculations, which is happening in their subconscious mind, which so that's what make them feel math as a very easy subject. Whereas a person for whom math is very difficult or tough, maybe what they are doing is they're trying to remember everything, or they're trying to mug up. Or if you what happens is, if you take your brain, you have these 7 to 8 slots for short term memory, where you understand things. And if you use them all, and if the information is still coming, then you are making your short term memory full. Yeah, then everything is overflowing over your head, right? Whereas if you find a way to connect what you're learning to somewhere outside, what happens is you don't have to mug it up anymore.
Right.
You have a way of remembering it or recalling
Mm-hmm.
it, right? It
Mm-hmm.
becomes your subconscious memory, it becomes your muscle memory. And then when you work on that subject, or you work in that language, you find it very interesting, actually. And then it is not tough anymore. Imagination is a very big part of learning mathematics, and they
Okay.
need to imagine more.
Right. One important ingredient for mathematics is imagination, but another one
Absolutely.
also would be intuition and guessing.
Yes, yes,
What do you
absolutely.
what do you think they bring to the sort of
Yes,
table here?
intuition and guessing are really, really crucial, actually. I'll tell you why. Because every time, let's say, if there is a theorem about angles, in geometry, we did a lot of theorems which say that why this angle is equal to this angle, and prove that and that. And then what we usually do is we take a theorem and then we prove it. And kids do that. And what we do is we build this model in front of kids, and we say, this is a theorem, and here you go, understand it, right? And then just a second. And you understand the model. So we give them the whole house that is ready made, that is built, and we ask them to recreate it. And if they can't do
Mm-hmm.
it in the first go, we would say, oh, then there must be a lack of understanding. You might not be good at math. Whereas we need to show them how that house is built. Where are the guts and roots, and what is the process that has gone behind. And guessing and intuition does, that crucial part of where like, why did we think of this theorem in the first place? So we are, if we are building a house, or in this case a theorem, then we should talk about, okay, where am I going to build the house in the first place? How big it's going to be, or how many levels it's going to have. And that requires a lot of guessing and thinking, and doing a lot of trial and error. What we are doing is we are skipping all that, and we are going directly to the theorem. So intuition and
Mm-hmm.
guessing will help you develop that much needed critical thinking, basically, which can
Right.
be used if let's say, if some other problem comes which is absolutely new, and you have never came across this before. This intuition and guessing is going to be very handy at that point of time, in order to solve
Okay.
that problem.
Okay. Okay. Do you feel that maybe in the ancient world that people had to have a lot more of this compared to now? Now we have techniques like simulation and technology. Do you feel that this
Yeah.
whole intuition, imagination, guessing was more predominant in the ancient world, and hence we were able to build things like the pyramid and Taj Mahal and the other architecture marvels that are there?
Yeah, that's very interesting question. Answer is actually yes. I mean, we always wonder how it's so accurate, isn't it? And there is a lot of math obviously involved in that, considering the accuracy that has happened in those architecture. If you say Ajanta or Ellora, or if you say Konark Temple, you know. So we could say that. some of them did have understanding of mathematics, but there was also a huge part of intuition and guessing that was involved in that, because there were some mathematical theorems or ideas that were developed during those times. Ideas like Pythagoras theorem, it was developed during that era, or probably it was developed so that they could create such architectures. Who knows?
What are
Right.
the sort of implications for higher and specialized education? How do you think, let's assume math is studied at a higher level. How should
Right.
it be
Right.
approached in according to you?
I would say that teaching math should be at early stage. But the way you teach it has to be refined from early stage. It has to be nurturing in a way that even if you go for higher levels, you should be able to think creatively. Because there is something called intellectual defense. It is a mechanism
Mhm.
of body that when you are gone through this kind of one structure for many many years, and suddenly you are asked to do something absolutely different, you kind of become rigid in your mind. You can't think creatively. And in order to think creatively, you have to be you have to be more flexible. And if you, the
Mhm.
place where you can't be flexible and where you're rigid, that is the place, it's called intellectual defense. And that's where
Mhm.
most of us go. It's a
Okay.
and that's the biggest problem in the industry. You say that we don't have any more critical thinkers, you know uh, afraid of teaching them very complex concepts in math at a very early age. Why not? There are many games that I have designed which can teach very complex principles in math at a very early stage.
Is it possible for you as a maths teacher to make everything as interesting and relatable in math? I'm sure there are bits which could not necessarily sort of have any real life consequences, real life applications, for example.
um,
How do you sort of deal with that part of math?
So, this is what I would like to respond, and this is how I would like to respond to this question. It's the only reason why we couldn't find any resemblance with the outside world with few concepts in math is because of our lack of understanding, and not because of that it's not
Mhm.
possible. Because at
Mhm.
then we need to dwell more into it, because math itself is derived from outside world. It is
Okay.
created, the very essence, it's created so that we can connect. Why it becomes so important? Maybe because of, I mean, it's going a little off topic, but why maths is so important? Because maybe because of democracy. you know
Mhm.
uh, like people needed that some kind of universal um, trust that is happening, because earlier societies were very small and elite, and everything that was happening, the decisions were made in a room by elite people. Like if you take Britain, for example, in 1700s or 1800s, and this is the research done by historians over mathematics, that why math became so important over the period of time. Because they uh, all the deals were cut in, or discussed or finalized in one of the rooms. But as societies grew, everybody had their opinions. I have my opinion, you have your opinion. How do we come to the consensus of what could be work for both of us? And that's where probably people thought that numbers is that one of the ways where people can universally come at one level, and that's where they became more and more important. So
Right.
yeah.
So, do you think this whole numeracy or the skills with numbers or with maths is an
Mhm.
inherent is something which is inherited? Is it genetic, or do you think that everyone can develop it fairly equally?
Yeah, this is actually one of the biggest misconceptions probably we have, or myths we have uh, in the world today, is math, being great at math is a inborn talent,
Hmm.
because it is not. Or like, do you know how to play basketball the moment you're born? No, it's a skill.
Okay,
You
right,
have
right.
to, yeah. So you have to learn. You are obviously interested in it, first of all, that you should be interested in learning how to play the basketball, and then you go ahead and then you put your hard work into it, and that's how you become good at that. So it's the same with everything else. It's the same with language. Basketball was a very far-fetched example. Language, we don't know how to speak when we are born, but we never expected that, say, speaking certain language is a natural talent. Just like that, maths is it's a skill. you know. To be able to good at it, first you need to be interested in it. You need to open up to the possibilities of it. By just by being anxious or rigid, you're just closing the doors. As I'm saying, you are putting that intellectual defense right in front of you, between you and the math. And the moment you become interested, you become a learner. And the moment you become a learner, you do put your hard work, just like you do it for basketball or playing cricket. It's the same thing. I don't see any difference in,
Okay.
learning math or learning cricket. Actually, you can learn better, or you can do better at cricket if you are good at math.
So, what is the sort of tips or advice you would give to convince people who think maths is some really really something that they don't understand, like a black box maybe? What is
Yeah.
it that you will tell people or students to sort of
See, I have
overcome
this
that?
very interesting observation over here. Like, let's say, for example, let's say if in every morning there are newspapers. I don't know if they still come in the houses, because we never ordered newspapers. We always did it on the internet. We always get news on the internet. But let's say some people have a habit of reading newspapers in the morning. The moment you see number in mind, you do a lot of grunt. You skip the number and you read the rest of the text. It happens most of the times. Like 10,000 people, so that 10,000 become, oh, people became this, and they got infected, or rates are rising by what percent. We don't pay attention to the percentage. So my advice would be, start seeing the numbers differently. Try to see how you can connect them to the real world. Like, let's say, for example, let's say here somewhere in local newspaper, they said that so many people were infected by COVID. Let's say 10,000 people were infected by COVID. And if I sit and if I look at that number 10,000, I would see that, you know if this village where I am staying and nearby villages, the total population is around 10,000. So basically what they're saying, that everyone is infected by COVID, which is not a reality, right? So the moment
Correct.
you found a way to connect to that number, you understood that what is the truth, or how much is the truth behind what I'm reading. So it makes you quite consciously aware of your surroundings, the moment you find a way to connect to numbers. So that would be one of my advice, that start looking at them. Don't grunt at them and avoid them, because math is like a reality check. The moment you start understanding mathematics is designed to give you the reality check to around your social world and physical world that is around you. The moment you consciously start looking at it, you become consciously aware of what is happening around you, and you can find out the truth and the lies, and things become crystal clear in front of you, just by to be able to relate to the numbers.
Is there some examples of students you can sort of share, inspiring thoughts or experiences that you came across? Maybe kid who was afraid of maths and how you probably pushed him towards overcoming it, or creative
Okay.
solutions to the problems. Okay, that could be one. Yes, ma'am. Is there some example you can quote?
So, no, I do have all three set of kids. Like some of them who have absolute fear in math, some of them who are absolutely great at math, and some of them who are in between. You know, so one example that I remember is one of my students when he came across, because this guy is really obviously above average, and whatever we do in class is very easy for him. And we came across this one problem which he just couldn't solve. He just couldn't solve. And we are sitting there. Now, I had experiences where as I said, I never be much of help to a child. So I'm sitting there and I'm letting him struggle. I'm watching him, what is happening, and maybe we can try this. And he comes up with, why don't we try this? And I do calculations with him as if I'm his assistant or junior. And he comes to me, and after 40 minutes of struggle, we couldn't solve this problem. Class is about to end, and he said, I'm so glad I finally found something that I do not understand. And he was actually having pleasure in the fact that he is stuck somewhere, because that rarely happens to me. And I was so happy with that. And I say, stay with that feeling. And then take your time and come up with what more can come out of it. And next class we managed to solve it, which was incredible, and that was a really good moment for us. One child is really above average, but he is very academic, as you can say. The moment you ask anything out of the syllabus, uh, it becomes, he shuts off. So we have had seen visible changes through the month course that we have been taking the course with him, that he's enrolled, that that thinking process is changing, and that person actually ended up creating website for maths for younger kids. The moment you understand something, how do you know that you understood a subject? When the moment you understand it, you have this urge to share it to other people. You want to tell as much people as possible, and that is what is happening with one of my students, and that makes me feel really happy about how they're coming out and sharing their knowledge. And one of the student is really really weak, but I don't like calling students weak. I take that word back, because nobody's actually not good at math. It's not possible to be not good at math. They are always, it's just that they think that they're not good at math, and that's where the whole barrier is. And then in that case, I really like to connect on personal level with that child. So we talked a lot apart from maths, like how was the childhood and what happened. And turns out the guy was traveling a lot during younger years. They were going through a transition from one country to other country, and there was a lot of turbulence and change and a lot of friction that was happening in the probably in the family, because of the way they were traveling, and they were not settled at that time. And this happened to him around when he was 8 to 10 years of age. And this is the time where you learn basics of multiplication and division and all that stuff. And then he never really got the gist of it at that moment. And because our school structure is such that you're 10 years, okay, you should be going from fourth grade to fifth grade, and then he was
Right.
pushed on to the next grade, and that just didn't happen. And those concepts stayed there, not clear, and everything was coming on top of it. And then he was obviously making mistakes because he was not clear about the understanding of what is going on. He was going with the flow, obviously, but then we went back and we talked about the basics, and the moment it was clear, now suddenly he's really good at math. You're
Mhm.
also good at it. It's just that we just missed few bits and bits, which we filled the gaps, and now we see the difference. So yeah, that's how it
What
usually
is it?
goes.
Let me turn it around. What have you learned about maths uniquely from this? Is there an
Oh,
example you can tell me?
so much.
Something
Oh
that
my
the
goodness,
kid.
so much. I think one of the most important things that I have learned because of my teaching to these kids, and because of everything that I'm doing around, is the approach.
Hmm.
And I think that has made the whole difference in uh, my approach towards the language. I won't say it a subject, but I'm one of those students, former students, who was absolutely afraid of geometry. I never
Hmm.
did good in geometry, as you can see. But when the approach changed, my the way I looked at it changed. And the moment that happened, everything was just so easy.
Okay.
So that is what I have learned from them. Their questions, and their in order to make them good, or make them understand what is going on, or make them better at math, I actually happen to push myself to be a better person who understands math, or find those connections. So basically, I would say that if I wouldn't have been a teacher, probably I wouldn't have bothered so much to make these connections to the real life world from mathematics. So all this thinking process that has been happening for past half an hour, I think that has been developed only because I was teaching to someone else, teaching to kids, and I was really enjoying that process of give and take. So yeah, approach would be my answer. It really gave me a very creative approach to look at the math as a subject or language. Sorry.
Okay.